Hello, welcome to Wild Data Podcast. My name is David Finkelshteyn, and today we are diving into the DevOps for AI and real system with Evhen Kazmin, a DevOps expert with hands-on experience in Azure, AWS, Kubernetes, and large-scale automation. Welcome, Evgeny.
Good evening. Nice being here. Thank you for having me.
Tell us a bit about yourself, about your career path, and what fields of technology have you touched since you started your career?
Since the beginning of my career in DevOps, I've been in a lot of different roles because I've touched the world of fintech, the world of manufacturing, gas and oil industry, some of healthcare products, and lots of different startups and already established companies which provide uh, digital applications or digital platforms for users, for clients to thrive, to grow and operate in modern um, business fields. For the most, I've been doing for them infrastructure as a code, automation, some integrations, monitoring, you name it. I mean, the field of DevOps is really big, vast, and enormous. Just to mention everything that one can do in a single sentence.
Yeah, that sounds a lot. Let's try to break it down and get something interesting and useful for our viewers. But first, let's talk generally a bit about what we're going to discuss. And so the main topic, of course, on our discussion is DevOps. And because it's Pivotal's podcast, we can't go around AI. So let's talk about what is DevOps in general. How would you define it, and how is it involved in AI field?
In AI field, there are lots of parts where DevOps can be involved because when you build something big and demanding, you need to, first of all, keep everything monitored, keep everything scalable, or at least ready to be scaled. You need to build things that can operate large amounts of data. Uh, you must build things that need to operate at high capacities and high volumes of compute, and to be able not only to build but to control it, you need a person who knows how those control levers and those systems are being built in other fields, because as a lot of uh, a lot of industries have already implemented this approach and be applied to world of AI and machine learning.
Yeah, but let's define like what is it DevOps? What is it in general? Let's define this also.
In general, DevOps is, as we all know, it's a culture of making things work together from operation side and from development side, because every business, every real world product always consists of its, like, let's call it backend, where smart guys are building the product, building its boilerplate, allowing things to happen, calculations to be calculated, data being processed, etc. And there's operation side, where you provide your end users and customers with the ability to access and actually utilize your product. And in between all of that sits DevOps, because you can, and you, in modern world, you must build a system that allows your code to be efficiently, and this is, I cannot stress this enough, efficiently being delivered to your customer. And efficiency and deliverability of it is defined by the quality of implementation of DevOps tools and best practices from the sphere.
Okay, look, this sounds really complex, and think it might be still confusing and unclear for some of our viewers. So, for me, personally, the best way to understand something new and that complex as DevOps is through a real example. And I know you have quite a few uh, real projects you participated in. So, do you have any? I know you have so, but I have to ask. Do you have any projects in where you worked as a DevOps expert in the AI and real time system field?
Yeah, sure. I have a bunch of them. One of the most intense projects that I participated in was a migration of fraud detection system for digital security company that worked worldwide with payment systems. And one of the most challenging parts of that was that we needed not only to technically migrate it, but prepare it for usage of their homemade AI platform edition, um, which it was something new for them, and we needed to count on that the scalability of services needed to be implemented because before that they had technically a static code which was smart enough to do that fraud detection, but that was nothing related to AI. It was just doing like static analysis. Uh, so scalability was the first part. The second part was latency because when you do a purchase, you need to get your purchase result, like approval for your purchase for your transaction in milliseconds, and that's where we had to keep in mind that we have Cassandra DB and we have like payment services integration endpoints, and we needed to make those transactions not run in. I'm not even talking about minutes or seconds. These transactions inside our infrastructure had to take milliseconds for the real person at some other, let's call it, end of the world to get what they expect. They just, I don't know, they just take their card, do the payment, and they get a successful payment request. And that request had to be already analyzed and approved by the system that we were building. And secondly, as the migration took part, we would identify that client had no CI/CD, which we built for them. Uh, and we also included their existing chaff infrastructure as a code into that system, though chaff is not initially was designed for integration, but we did some custom scripting, we did some customizations to their existing deployments so that they were honoring the CI/CD approach and they were able to roll out code all together with infrastructure changes in the same bunch, again, as a best practice on a annual basis.
So this project sounds huge. I know we can talk about it like a whole podcast, but
Yeah.
let's try to focus on one thing at a time. So, what was the biggest challenge at in this project in DevOps field,
Um,
of course?
the biggest challenge for that project was keeping all the systems all together running like in unison because when you migrate something, there are always new requirements that you have to face. And for our case, it was the fact that client was running on the outdated OS, and we also had to uh, like do the upgrade for the newer and cloud supported versions of the OS, for which we had to overhaul the whole chef code, which was, I mean, it took the most of the time because uh, it was kind of slightly tedious, but it's something that we had to do to make sure that the client stayed safe and stable within their infrastructure, within their deployments, and all the footprint that we migrated. And that migration, I mean, when you do the migration, it always layers out eventually. First of all, you need to migrate something, then you find that you need to face some kind of a new requirements, and on top of those new requirements you can only then find out which system layout you may end up with, because all those layers, they dictate how you end up and when. Let's put it this way.
Okay. So if I recall, the biggest challenge was everything.
Yeah, I mean, when you migrate, the biggest challenge is like you have lots of streams that you need to accomplish, and making that come all together at a certain point, which hopefully matches the deadline agreed initially. That's, I don't know, that's the biggest bingo you can ever have.
Yes, yes, yes. I understand. I mean, everyone who have ever participated in the software development, especially for startups or for a company that want make a leap in their like technology stuff for sure. Everyone will understand what I'm talking about.
Yeah,
But yeah, so okay, let's keep the pace and move forward. Tell me, please,
sure.
how DevOps enable real-time AI systems?
When you want to work with real-time AI system, DevOps is a person who is going to prepare a boilerplate for your AI to run on top of. Because nowadays we're far from running models locally using our local GPUs, etc., etc. So when you're doing some kind of a cloud deployment, some cloud development, and you want to have everything to be modern and follow the like up to date practices, you need a good DevOps who can find out what you need for your AI system. I don't know, some platform as a services, software as a services, and implement that for you to do your development faster, to roll out your models at a time, not when they are like when everything's ready, but when, right when it has to be done. Uh, Monitor everything. I don't know, for example, see like model drift, data ingestion volumes, understand the load on the system and how the system has to be changed to handle everything you throw at it. And that's the key components of like creating stable, running, and again efficient AI real-time systems.
Yeah, okay, this is I'd say pretty clear to me. So I know we already touched this a few times, but I want to put it in a separate part of our conversation. So, what is unique challenge or challenges that DevOps encounter in AI, like during developing AI software compared to traditional software development?
Um, I mean, from my personal point of view, one of the biggest challenges is that we've came up to the point where your ML models, they need to be versioned. They need to be, again, doing the things that DevOps do, doing the CI. They have to obtain the ability to be integrated right away. So when you push your code, your I don't know, like some improvements to your scripts, etc. Those need to be integrated right away so that the learning starts right the moment you do the commit. And in that moment, DevOps comes into help building the system that allows you to integrate your updates right at the moment when you do the commit. The second part is that, again, observability. Observability is something that IT world is struggling every day because you need to monitor things. Without monitoring, you technically are in the black. You're not knowing what is happening to the system that you build, to your models, to everything. For example, you can take Grafana and build your monitoring system the way that you can even see the modal drift on a sort of dashboard so that you don't have to go there, check stuff, etc., etc. You can just see it graphically and really easy to consume for a person working in a tech company. And the third point nowadays with NVIDIA doing their stuff, cloud providers doing that stuff, you can get GPU auto scaling so that you can have a system that will cost you tons of money if you just spin it up and keep it idle just because at the moment you're not running something. And with ability to scale up GPU and scale down, scale out any type of scaling, you can obtain an efficiency of just paying for what you've consumed just for that certain period of time. You do the training, you pay for your resources, and then everything's down and you're in a good place because you're not paying for just having that resource existing. You're paying for what you consume.
Yep, this is really useful thing, not only in AI but in AI especially because it's so resources consuming field, and I can tell from myself that we using ML Flow framework for MLOps, and it works very good for us. Next question will be about infrastructure automation, and I'm wondering, are there any examples where you which shows how infrastructure automation saved time and resources in AI deployment?
Yeah, sure. Regarding the AI infrastructure automation, I reckon one good case because everyone knows that having a database technically is a must for modern type of application. And when you have a database, at some point, the security dictates you that you need to do some password rotation, etc. And when that database is constantly being used by your application, you have to either organize some downtime or expect some unexpected outages because of data being inaccessible by the system. And what we did is we've implemented, with help of Terraform and regular CI/CD tools, a mechanism of rotating password each time the application is deployed. So first of all, I mean that covered and did even created an even bigger gap than is required between password rotations because average password rotation requirement is at least once a month for different types of data that may be bigger or smaller. And the client had deployment window each day. Technically, at the end of the day, they had all the recent changes, data changes, code changes, which were already committed and tested, deployed to their system. And each day they had a new password which was generated before the actual application was deployed. That password was generated securely stored in AWS Secret Manager. And right at the moment when application was deployed, it got inside just by referencing the type of secret in Secret Manager. And in this way, we created a closed system of password rotation, which did not um, did not involve any of professionals being dedicated to it. It was executed automatically, and it saved that precious time for the modal data access, which may occur when you're running, again, like real life application.
This is a really cool solution of a complex problem, I'd say. I like this kind of solution. Uh, and yeah, so I talking about automation and scaling and managing resources in AI field. I know that Kubernetes is wisely used for AI, and also I
Yeah.
know that you're a big expert in Kubernetes. So let's put these two things together. Evgeny, please tell us about how optimize real-time AI workloads using Kubernetes.
Yeah, Kubernetes is I don't know how to put it, is a big transformer that can do everything for you. It's not limited to something. It's just the matter of you being able to find out the way to obtain something. So with Kubernetes and AI, we have lots of different cool things that we implemented and which me and people who, for the most, I work with, find really useful for it. First of all, is so-called kata autoscaling. This is a functionality of Kubernetes being able to respond to some events, not, I don't know, like not metrics, not logs, but events. So, for example, you have some queue service, and when the event happens, you can auto scale. I mean, you know that at this point there's a process of, I don't know, either learning or some compute is going to happen, and when that event happens, it might not even have already started its process of, let's call it processing, yeah, but you get it, and before the processing of the request starts, you already have, I don't know, like a new pod for execution spun up, or you may have, I don't know, like for example, additional memory added. You have that auto scaling in your hand, and when that event is down, again, we have scale down automatically because, for example, in your initial Kubernetes configuration, you don't have that much, for example, volume of compute power designed like in idle state. So this is the first thing. And secondly, Kubernetes provides you with the ability to have rolling updates, which, again, with the proper configuration, can bring you up to zero downtime deployments. So, for example, it's not the fact that when you start your deployment, your service goes down, there's a certain amount of time for service to be actually deployed, and there's a certain amount of time for service to spin back up again. But with Kubernetes, it allows you to first deploy your new service, then wait for it to, I don't know, like for its startup. You can have a health probe that will go into effect when the service is technically up. But again, at the moment when service is technically up, not everything may have already been loaded into it. It's not fully capable. And you may have, for example, readiness probe. For the readiness probe, you can configure your internal service mechanisms to respond the readiness probe only when like internal checks have already passed, so that the service is up, it's connected to the database, it's connected to the modal, it has all the scripts and all the dependencies in green, and only then begins the process of traffic transfer. Because until that readiness probe is sufficiently hit by the Kubernetes endpoints, everything still goes to the old service. And when that new pod with new service is ready, it starts flushing connections from the old pod and putting them into a new one. So you have seamless change of the service. Yes, in terms of uh, rapidness of people getting to the new service, it's maybe not perfect, but you don't have that unavailability of service for end user. And this is something, again, in my world, this is amazing because end user or end client gets a seamless transfer from one to another. Plus, these approaches allow you to, for example, create ability to do kind of a like canary deployment so that you keep both services up and you transfer only some certain amount of traffic to the new one so that you have like that A/B testing, etc. You can collect response, collect metrics, and then decide on whether to switch to newer implementation or not.
Okay, this is a lot, and since we already uh, understand now uh, all these advantages of Kubernetes being implemented into the AI software, AI core software with AI as a core. Um, let's talk about hands-on uh, advices you can give us. So, what's your approach to Kubernetes monitoring for AI workloads?
Um, I mean, that approach wouldn't differ from any other approach because, like, the tools are the same. It's just a matter of what you're monitoring with. The perfect and technically well-known approach is Prometheus plus Grafana because Prometheus is amazing in terms of getting metrics, getting system, let's call it system health vitals to understand again what kind of stress you're putting onto your systems. Secondly, there are different approaches. There's ELK stack, so-called Elastic, Lodash, Kibana, but in my experience, the better way to see the logs is Fluent, Loki, Kibana, or Grafana. It's just a matter of taste because that system is light and efficient enough. Uh, Maybe it's not the best when you're doing like enterprise level thousand model, some monstrous ecosystem, but when you're having your product concise and technically everything is streamlined as one product at the end of the day, this is the best approach because it does not require a lot of resources to run on, but it still does the log aggregation successfully, and it's almost just in time logging because the latency period is fully depending on how you set it up, and something like 30-second uh, time frame between the log has actually been generated in your application until you can see it somewhere in Grafana is something that even nowadays treated to be a good one. And the last thing for your platforms you use, again, to my liking, those are like cloud provider provided logging systems because they have good level of integration into what you're running on because AWS CloudWatch is amazing and great for monitoring, for example, your EKS cluster or ECS container instances, just because it has a great level of integration into the system. And again, it runs efficiently and CloudWatch is, for example, and at the same time is Azure Monitor. I mean, it's great. They do lots of stuff. And both of them are easily integratable into your Grafana as data sources. So then at the end of the day, you can get all the logs, all the metrics, all the systems all together in one place, being able to analyze, being able to parse everything into what you need. And on the other hand, those systems by themselves, CloudWatch and Azure Log Monitor, uh, they can be utilized as separate systems because, uh, except for CloudWatch just providing you with logs, you can configure alerting based on them. Those systems are already embedded. Then why would you need to create a zoo of tooling when you have everything already done for you? You just start using it and benefit from it.
Okay. Yeah, this is sounds completely reasonable to me. And since now we know everything about Kubernetes and AI, and me and all our viewers uh, can give a lecture about Kubernetes. Let's talk a bit about disadvantages and probably some potential issues with Kubernetes. So I want to ask you: have you ever faced a major AI related Kubernetes failure?
With Kubernetes failure, sometimes failures are not related to Kubernetes. And from my experience, for the most, it's not related to Kubernetes, even if you're using it. For the most, events that actually led to some troubles and unexpectancies, it was lack of, for example, planning, or maybe lack of understanding what you're trying to work with. Because with Kubernetes itself, uh, it's not a something problematic to count how much stress. Again, if you haven't implemented your monitoring, you don't know how much you're stressing the system, and you don't you cannot calculate when you're gonna run out of juice for your models, for your application, etc. And when you roll out something new, you always have to count on that the resources that you've planned initially, they are not endless. At some point, you're gonna hit the bottom of, for example, RAM, CPU, memory, storage, etc. You need to plan all the changes, and again, that's where monitoring that we discussed comes into hand. But the second part is when you're running infrastructure as a code, there's something that you have to bear in mind, that when you're doing infrastructure as a code, you need to keep things considered, because at some point you make some smaller changes. For example, I don't know, updating something, for example, some provider for Terraform, and you may end up with new provider having, I don't know, like different notations for security. I don't know, like for some access or the availability of your data to like to public. I mean, we had a case when we did the upgrade, and that after deployment of that code in Terraform, we ended up with data sets being available publicly, which was actually a great disaster, because if they flew into the wrong hands, that may have caused big troubles for data providers, for for the clients of mine, which I was doing these things for. And with help of AWS Security Hub, we were able to promptly find the issue, investigate what caused it, and swiftly like just fixed it. So all these levers of informating you as a company of what is happening to your products, to your applications, to your systems, is a key to being safe, especially when you're hitting some regulations like GDPR or HIPPA, which is one of the the main regulations when you do the healthcare.
Yep. Okay. I now understand. I understand that Kubernetes is perfect. Only humans are imperfect.
Yeah,
Humans cause all the issues. I hope AI is not listening to me now. Uh, so yeah. Okay. Let's follow up on this topic. It's quite interesting actually. Let's talk about how do you ensure that AI deployments are safe in production?
again, we've already touched base on
Yeah.
like general security, and when you're doing when we dig a little bit deeper into security of the AI models themselves, when you're trying to roll out some model or some some machine learning uh, scripts, for example, yeah, you need not only to test them internally with testers, QA team, etc. You need to make sure that they provide a proper responses. And the best way when you're rolling out completely new model is to try something, for example, like canary deployment. So you do the deployment side by side. I've mentioned it is easily feasible with Kubernetes, but modern AI toolage of cloud provider also enables you with that possibility to configure some kind of a slots to place both models and do that AI testing, for example, A/B testing, so that for some certain amount of your users, you're rolling out a new model, for example, for 1%, and you do like the feedback and analysis. Yeah, you can see what the model provides and you user with, and you either can tune it or like improve it. And if that works perfectly, you roll out 10%, 50%, 100%. It's just a matter of you choosing at the end of the day. But this provides you with the ability not to, let's call it, not to upset the majority of your users with some unexpected results, because building that model, you cannot predict everything that user is going to throw at it. So these real life testing is something that brings you with the security in terms of understanding what's the output of your work is.
AI often handles sensitive data,
Yeah, it
and
is.
what is the best practice to keep our data safe?
Um, mm, okay. Data security is completely like thing in itself. It's not just a practice; it's a whole field, and there are separate specialists who work on data security and general security compliance things. But as a DevOps, I need to implement certain tools and certain practices to follow those regulations. And first of all, one of the most important in keeping the data safe is uh, access management, because for last about 10 years, something that's been frequently discussed and was said to be a good practice is least privilege access. So before you provide your system with the access to some sensitive or any data, this is good for any data. You need, first of all, to sit and define what kind of the data it needs to access and what specific information it needs to work with. Because when you have a big data set, um, in real life, it turns out that not all of it needs to be accessed to you. So you may split vital data and like general data, for example, and for different data, like you split them in different data sets. And for those different data sets, you create different access level policies so that the system may interact with them in an efficient way. Uh, that's that's one of the biggest challenges with that. So again, I've mentioned the second part of data security is secret management. Uh, I know that in the old days it was okay to create some file with your secrets stored there or provide your, I don't know, your application with env file and just write all the necessary things there. But nowadays it's first of all unsafe because let's call them bad people who want to somehow interact with you in terms of grabbing the data. They know how to get it, and the only thing to keep things secure is to use some kind of a secret manager. In AWS it is it's called the same way. It is a secret manager. And for example, in Azure, you can use either Key Vault, which technically does the same as the secret manager. It keeps your vital, I don't know, like connection endpoints, security credentials, etc., certificates. Uh, it keeps them encrypted and safe from from the bad guys. Plus, for example, in Azure, you have such things as app config, which also stores, for example, vital endpoints for your service. But why it's called app config? Because it understands that your system may run on a different environments,
Mm-hmm.
and based off the environment it is running, the app config will provide you with a different value so that your system is addressing app config and saying, give me, for example, I don't know, database endpoint. And app configuration will know that this is, I mean, it has three values for like, for example, three of your environments. And based off the environment that the application is giving it, it will provide with the certain credentials. So this brings another level, like another layer of logical security, because without understanding which exact environment it is, you will never get the value. And this is something that has already been implemented in many situations. And I've even seen that what people did, they did environment names based off encrypted values of certificates. They just took certificate fingerprint, and that was the name of the environment, and that brings even higher layer of security, because without understanding the fingerprint, you will never get the environment name. And the last thing is just general awareness, because um, in our up-to-date world, we have lots of regulations, and as a DevOps, you have to be aware because there are ISO regulations, there are GDPR, which I've mentioned, HIPPA, which I've mentioned, and many other local local regulations that you need to face and to be aware of, uh, as well as industry standards if you want to go global.
Okay. Yeah, I'm pretty sure that many of our viewers will find this uh, thought and advices are very useful. Um, so let's uh, quickly talk about why we need this. I mean, it's obvious why we need to keep our data secure, but maybe if you can briefly mention an example of a security failure you may encounter during your career, it will help to understand the importance. of following all your suggestions you gave us before.
Yeah, one of the issues that we had at some point with dataset being available to the world, I've already mentioned that. And for example, secondly, we had uh, with one client, we had a problem that they got their uh, database credentials just stolen. And eventually, with no password rotation policy, with no security controls, for example, like, I don't know, like uh, database connection monitoring and getting alert when the connection is happening from unsolicited or unexpected place, they may have been able to predict that someone is trying to steal their data from the database. But as no of these controls were implemented, they ended up with data being encrypted. And I know that for lots of people, this has happened all over the world, where like the data has been encrypted and there's a node that sends some amount to some cryptocurrency wallet and will provide you with an encryption key. But that's, for the most, is just a scam, because no one's gonna get a key and data is never gonna get restored. But at the end of the day, with automated backups provided by Azure, with like snapshot backups configured by database administrator, with everything, we were able to mitigate the problem, because that was a certain cluster, data cluster, which included something around uh, 6,000 user data. And the second part of it is that the data, I mean, the most important thing is the data has been encrypted, because without encryption on the MS SQL, you will not get consistent data. So it was both ways unusable. So we just dropped that infrastructure, and with everything configured to be deployed as infrastructure as a code within 24 hours, with all the backups, we were able to restore full functionality. And that was the point where management decided, no, we're gonna need to implement um, PKI technology to oversee our passwords. We're going to implement mandatory password rotation. We're going to implement automated policies that are going to check who and where from is connecting. And when that happens, it's easier for us to block, I don't know, some person who decided to do the workation in the Thailand, and then let him do his work, than to face these failures with some attacks, with data being stolen, etc. So these controls, at the end of the day, they may bring complexity to your day-to-day work, but it keeps you safe from people who want to harm you, from DDoS attacks, etc., etc. I think that that should answer the question.
Yeah. Uh, to sum up, uh, follow Evgeny advices, work with Pivotal, and your data will be secured. Your services will be up and running. Okay, last question. Let's because we are running out of time. Let's try to give a short answer to this, but still, it's a really interesting and important question. Where do you see DevOps for AI going into the next, let's say, 5 years?
Um, Next 5 years. Let's start with my area of work. I feel that AI is going to enter DevOps world not from the side where DevOps manages AI and manages everything for it, but I believe that there are upcoming tools which gonna help us to work better, because AI is something that can do really feasible and understandable predictions. And in DevOps world, having a prediction for the possible failure is already good enough to investigate that. So I think that at some point, AI is going to enter world of helping DevOps, helping AI work better. It's going to be some kind of uh, cursed circle in a better way, because by making our work easier, AI is going to make its life more efficient, more capable, and more evolving. Plus, I've already heard that there are some rumors about um, how's it called? I think it's MLOps 2.0, something like this. Uh, it's gonna be something around doing more efficient model training, self-trained models, and maybe some kind of, again, more efficient model retraining. Maybe, I don't know. That's my assumption. I expect that to happen, but not particularly sure that there's anyone already working on that. And one of the biggest things that I see, like expansion of IoT nowadays, and getting that AI edge calculations, AI, um, just running that model on the edge device, bringing up latency for data transfer technically to zero, because I mean, you get some input right where you're running your model. I think that's going to be the next thing that we may see, because I don't know, like seed infrastructures, big production companies with I don't know, like big manufacturing sites, they have ability to implement monitoring devices, some sensors, etc., etc. And when data from that sensor, or I don't know, like monitoring camera is being analyzed right where it's tuned, and getting the output in form, for example, alert, that alert is, I don't know, like a couple of bits that's going to fly in milliseconds to the other end of the world. You don't have to pull the whole like video stream and analyze it somewhere, and then, I mean, it all takes time. The closer you bring things together, the more efficient that they're going to work. And I think that idea is like the AI and ML world most close future, and most realistic way of developing in nearest years.
Okay. Yeah, this is an interesting point, and it was an incredible conversation. Uh, Please follow Evgen. Follow Pivotal, our YouTube channel, LinkedIn page. We will have everything, uh, every link of Pivotal and Evgen attached under the video in the description. And thank you. Thank you again. Thank you, everyone who is watching us, and see you in the next episode. Bye bye.
Thank you. Have a nice evening. Bye bye.